Greetings, welcome to this new video about mesh analysis method. Solve the problem number 9. In this video, we will see how we can derive by inspection the mesh current equations, and I will show you how you can solve that using MATLAB. Keep in mind this method is valid only when a resistive circuit contains only independent voltage sources. Given the electric circuits consisting of 7 resistors labeled R1 through R7, as well as the 3 independent voltages VA, VB, and VC. The question now, by inspection, find the mesh current equations and determine the mesh currents. Let's move on to the solution. The mesh current equations are given in matrix form as follows. Ri is equal to V. In this circuit, we have 5 meshes, so the dimension of the resistance matrix is 5 by 5. I present the vector of the unknown mesh current in the clockwise directions. V is the input voltage vector which has the terms in volt. This is our resistance matrix R. Let's start first with the diagonal terms of R. R1 is the sum of the resistances in mesh 1. This is mesh 1. We have R11 is equal to R1 plus R2 plus R6. We get 50 plus 20 plus 80 is equal to 150. R22 is the sum of the resistances in mesh 2 is equal to R2 plus R3 plus R4. We get 65. Let's move on to R33. In mesh 3 we have R3 plus R5. We get 50. Let's go to R44 is the sum of the resistances in mesh 4 is equal to R4 plus R6. We get 95. Let's move on to the last one. R55 is the sum of the resistances in mesh 5 is equal to R5 plus R7 is equal to 80. We go now to the off-diagonal terms of R. R12 is equal to R21 is the negative of the sum of the resistances in common with meshes 1 and 2. This is mesh 1 and this is mesh 2. The common resistance is R2. That's why we have negative R2 is equal to negative 20. Let's go to R13 and R31. This is mesh 1 and this is mesh 3. There is no common resistance between mesh 1 and 3. Then we have R13 is equal to R31 is equal to 0. Let's move on to R14 and R41. This is mesh 1 and this is mesh 4. The common resistance is R6. That means we have negative R6. We get negative 80. We go to R15 and R51. This is mesh 1 and this is mesh 5. There is no common resistance. So R15 is equal to R51 is equal to 0. Let's go to R23 and R32. This is mesh 2 and this is mesh 3. The common resistance is R3. Then we have negative R3 is equal to negative 30. We go to R24 and R42. This is mesh 2 and this is mesh 3. The common resistance is R4. That's why we have negative R4. We get negative 15. R25 and R52. This is mesh 2 and this is mesh 5. There is no common resistance. So R25 is equal to R52 is equal to 0. Let's go to R35 and R53. This is mesh 3 and this is mesh 5. The common resistance is R5. That's why we have negative R5 is equal to negative 20. Let's go to R34 and R43. This is mesh 3 and this is mesh 4. There is no common resistance. That means R34 is equal to R43 is equal to 0. Let's move on to the last one, R45 and R54. This is mesh 4 and this is mesh 5. There is no common resistance, so R45 is equal to R54 is equal to 0. After we finish from the resistance matrix R, let's move on now to the input voltage vector. We start first with V1. Is the sum taken clockwise of all independent voltage sources in mesh 1 with voltage rays treated as positive. This is mesh 1. We have only the independent voltage source VA. If we go in the clockwise direction, we have here voltage rays. That means we have plus VA is equal to 30. In mesh 2, there is no independent voltage source. That means V2 is equal to 0. And in mesh 3, we have only the independent voltage source VC. If we go in the clockwise direction, then we have voltage drop. That's why V3 is equal to negative VC is equal to negative 12. Let's go to mesh 4. We have only the independent voltage source VB, and if we go in the clockwise direction, we have a voltage raise. That's why we have plus VB is equal to 0. Let's move on to the last one. In mesh 5, we have only the independent voltage source VB. If we go in the clockwise direction, we have a voltage drop. That means V5 is equal to negative VB is equal to negative 20. After we finish applying the mesh analysis by inspection, we obtain the resistance matrix R and our input voltage V. Since this problem is quite difficult to solve, I created a MATLAB program that makes it easier to solve, which is shown with this figure. Let's go through this program. We start first with the matrix R. This is row 1, row 2, row 3, row 4, and row 5. We can see here that all rows are separated by a semicolon. Let's move on to vector V. This is row 1, row 2, row 3, and row 4. Is the same here. All rows are separated by semicolon. And we can see here that I is equal to ln_solve R V. Ln_solve is actually a function used to solve linear equations in matrix form. After we run this program, we obtain the values of the mesh current, which is given as follow. I1 is equal to 703.9 milliamps, I2 is 347 milliamps, I3 is negative 146.4 milliamps, I4 is equal to 858.1 milliamps, and the last one, I5, is equal to negative 286.6 milliamps. Those are the results obtained from MATLAB. Let's go now to verify those results with the result obtained in SPICE simulator. Here is our circuits in SPICE simulator. I designed, or I called the current through the resistor R2 by IR2, the current through the resistor IR3, the current through the resistor R5 is IR5, the current through the resistor R7 IR7, and the current through the resistor R6 is IR6. Now we can see here that IR2 is equal to I2 minus I1. IR2 is equal to I2 minus I1 is equal to 347 milliamps minus 703.9 milliamps. We get negative 356.89 milliamps. This is the value obtained from MATLAB. Let's go now to SPICE results. We go to analyze, DC analysis, table of results. we can see here that IR2 is equal to negative 356.89 milliamps is exactly the same value we obtained from MATLAB. Let's go now to IR3. IR3 is this current through the resistor R3 is equal to I2 minus I3. We get 347 minus a plus 146.4. We get 493.4. Is exactly the same value here we obtained from SPICE simulator. If we continue the same for IR4, IR5, IR6 and IR7, we will have the same results. So the results obtained by MATLAB is similar to the results from SPICE simulator. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. Have a nice time and see you next time in another video about mesh current method. Bye bye.